Okay, this is TempleOS 5-minute random code walkthrough, episode 55, and I'm your host, Terry Davis. Let's see where God takes us. We are in DC to dock. Okay. So, this is one of my personal files. It's for if I have a screen capture and I want to make it, let's say I have a screen capture. Where's the screen capture? Let's go to this is my website files. Let's put this. Okay, let's go to my home directory and make a little program. CDC star DC equals BMP read file dither probability makes it DC. Okay, so BMP read, and then we say did you know if you press F2 you can not F2 F4 you can select a file name. F4 is a file name. So I just let's take a look at here's what I'm doing. I have a bitmap file that I'm going to type on the command line, and you'll notice it has text, and what we're going to do is reverse the bitmap and make it back into text. So we're reading the bitmap file. Let's plot it on the screen just so you can see. GR blot, comma, and then 00, comma, DC. Let's make sure I get this right. If I crash it, it would be bad. Okay. And then we say get char, then DC fill. So this, okay, did you see that? That's my screenshot. Now we call the DC to dock. This is, now if you want to know where this file is on your disk, go to demo, count example, Atom, DC to dock is in here. So we want the DC, the X and Y. Okay, so now we say DC to dock, and it makes a document. C dock, star dock, DC to dock, DC dock equals, and then we say dock write dock. Now technically we should we say dock delete dock, and we also say DC delete DC. Doc write we should set the file name, I guess. A document has a, okay. Let's see if, oh well, let's just do this. Here we go. Now if we go to my home directory, we have a file called temp. And this is the document has been converted to text. Okay, so maybe we want to, all it does is it goes through all it goes through all rows, it goes through all columns, then it goes through all the bits in the wait. It makes a binary image, first of all. Okay, so it's peaking, and if it's not white, then it sets a bit. So this is making a 64-bit, it's an 8x8 font, so this is a 64-bit bitmap. Cur image character is a 64-bit integer, so we're using an integer as a 8x8 bitmap. And just prior to this, we set up a we count the number of bits. So then we go through all the visible characters, 32 to all the ASCII characters, and we XOR the image from the bitmap, the image from the device context. We XOR with pointer points to the font. Text.font is the system font, and we XOR to get the error bits, and then we count. We prepared a table for the count of bits, and then we add an error score, and if it's better than, so we're seeing which of the characters scores the best, and then we write it to the rewrite the ASCII to the output document.